Okay, I like to go to opentopography.org to find my raw point cloud data, and if I want to make a DTM or DSM, sorry, I'll make it from here. So if I go to the Find Data Map, and if I scroll down and go to the next page, you'll see that there's something that says New Zealand, if I'm there, and this has a list of all of the LiDAR datasets that have been created from most recent to latest. So if I zoom in on a little spot that I've been working in recently on Takaka Hill in Nelson, so if I draw a box around an area of interest, I'll deliberately pick a very small one. You can see it's given me quite a few recent data sets. And if I want, I can go and get the point cloud data from one of those recent data sets. You can see that here, that recent data set is probably just getting split. So I'll check one of the other recent data sets, and I'll get the point cloud data. This is free to log on and sign up for. Essentially, you scroll down, go to the standard classifications, and get rid of everything except the ground. If you want, it will actually create a DTM for you as well. If you pick a frivolously small number, it will tell you what the minimum recommended resolution is. I actually prefer to make a data 10 out of the points. Instead, hit OK, use whatever email you signed in for, and hit go. This is a relatively small site, so it should download quite quickly. But instead of using the lens dataset, which is crunched to an elevation model in the order of 1 meter, this has the full, I think this dataset is probably 30 points a square meter. So we're down, I guess, in a 1/4 meter resolution. And you can see that it's going through an extraction process from that data set. And the reason I'm leaving it going is because it really does not take a long time. Oh, excuse me. Yeah, so here we go. It's just in the middle of creating the data sets, and I can now download the point cloud data. You can see it's downloading up here. And I can also download the tin, and you can see that's also downloading. Now, if I want, I can download the LiDAR 10. Oh, it didn't like that. Oh, there we go. And yeah, I'll just grab it from here. So if I drag that onto my GIS software, I'm using Global Mapper because I'm very fortunate. Yes, it's elevation data, and you'll see that it creates a surface. The surface is a little bit fuzzy, but you can see that it's quite granular. There's really a lot of detail there. Or what I could do is I could go to the last file and do the same thing with that data, make an elevation grid, hit OK, and hopefully if I zoom in on this, you'll see that there's a crystal clarity change. Yep, where that's the provided tin, which is a little bit softer than the nice crispy triangles that are made from the data set. And here I'll do a simple thing where I will configure it into a local circuit. I don't like working in NZTM. The best practice is to find the most local circuit, apply that, and then I can right click that, layer, export, and make it into a TIFF, and I can choose what resolution I want to have that tin or surface exported at. And generally, I hit it at 0.25 meters. I've found that 0.25 meters generally doesn't deviate from the best tin an awful lot, but if I go up to 0.5, I definitely end up with a new surface which is sitting generally high of the triangles. Hit OK to that, save it to my downloads, give it a test number, and hit yes. And it doesn't take too long to save it, and that's it. That's literally as easy as it can be. It slows down a lot if you're getting bigger data sets, and of course I might choose to make contours of this, but that's a good way of doing it.